Hello everyone. So today we are going to discuss a topic from the chapter of Moving Charges and Magnetism. When magnetic field is in a region of certain width, now suppose we have this kind of a situation where a charge enters like this and assume charge is positive. Now if I do V cross B, I know magnetic force from V cross B. Magnetic force will be in this direction. Say this width is D. If magnetic force is in this direction, the center of the subsequent circular motion will be here somewhere. This distance will be R. ये distance R होगा. So the particle will take a trajectory like this. And when it reaches here, it moves out with the same speed V. Now why the same speed V? Because I have already told magnetic field will not do any work on a point charge, correct? So speed will remain same. Okay. Now if I call this angle as theta, this angle will then be 90 minus theta. So this angle then becomes theta, correct? Okay. This length is also R. And this length we know already is D. So can I write sine theta is D by R? We know R is equal to mv by bq. So by putting all the values we can get R. And if I know R, I know D, I know sine theta. So effectively I know theta. Correct? Effectively I know theta. Now, if I talk about deviation, the initial velocity is in this direction. And final velocity is in this direction. This is the angle theta. So deviation is theta degrees, and we should always say the sense. That will be anti-clockwise. How much time is being spent? How much time is being spent? So can I say about the center, it has covered an angle of theta. So time spent will be theta by omega. And omega is, as we know, bq by m from our previous discussions. So time taken will be right. So remember, this theta has to be in radians. This theta has to be in radians, right? So I have not discussed a generalized case. I have discussed a particular case where the initial velocity is like this. right? Let's move forward then. Okay, look at the question. It says you have to produce a deflection of 30 degrees. So I'm saying this has to be the condition then. If this is 30 degrees, this I know is 90. So this will be 60. This again is 30. If you find out this width, this is B minus A. So this length is B minus A. This is R. So sine 30 degrees is B minus A by R. So half is equal to B minus A. R is mv by bq. So V is if we find out, this matches with option 1. Right? This matches with option 1. Clear? Okay. The other case then is when angle between initial velocity and magnetic field is other than 0 degrees, 180 degrees or 90 degrees. So I'm saying, suppose this is the condition. Magnetic field is in positive x. Velocity is in this direction, making an angle theta. Okay. Note one thing, and this is for every case. Note, we will always place that axis perpendicular to plane of paper along which magnetic field exists. Along which magnetic field exists. So in this case, we first break the velocity into components: v cos theta, v sin theta. Now, since field is along x-axis, so I have to place x-axis out of the plane. What I will do, this is y, this is z, but automatically then y cross z has to be I, so z axis will be out of the plane, positive z. Now magnetic field is out of the plane. There is one component v cos theta and there is one component v sine theta. First of all, we try to understand what is the subsequent trajectory. Okay, obviously this v sine theta component, due to this, since field is perpendicular to it, there will be a circular motion in yz plane. So circular motion in yz plane, but there is a v cos theta component which is along the b vector. So can I say this v cos theta will remain unchanged, or there will be no change to this velocity, correct? Because due to this component there will be no force, v cross b. So v cos theta cross b is 0, so this component is not going to change. So can I say there is a straight line motion along x-axis? I'm talking about in this question for particular. So can I say, if you try to analyze this, you are going to get a situation like this. You are covering a circle and you are going in a straight line. You are going in a path like this. And this is x-axis. This kind of motion is known as helical path or helix. So when I combine circular path and straight line, I'll get this resultant, which is a helix or helical path. Now let's try to understand both of the motions individually. Okay, now let's try to understand both of the motions individually. First, analyze motion in YZ plane. So what you can do, this v sine theta can also be written as perpendicular component, and v cos theta can be written as parallel component. So this is v sine theta, which is the perpendicular component. Now if you do, this is direction of b. If you do v cross b, that turns out to be downwards. So magnetic force at this instant will be downwards. So center is obviously going to be downwards. Center is going to be downwards. Okay. So this particle is going to move like this on a trajectory like this. Okay. This is the circle. Say at an instant it is present somewhere here. So obviously by that time it would have covered an angle of omega t. So if I get this length, this is r. This length will be r sine omega t. This length will be r cos omega t. So if we are looking for coordinates of this point, it will become r sine omega t minus of r, 1 minus cos omega t. Because this is going to be the z coordinate and this is going to be the y coordinate. And this is the y coordinate, this is the z coordinate at any given point of time, right? You can have a look till here what we have done. Okay. In x direction, we can say we have the v parallel component, that is v cos theta, that is going to be constant. So I can say x final minus x initial is v cos theta into t. That is displacement equal to velocity into time, since velocity is constant. For our given condition, this is going to be this. So this is how we can write x coordinate as a function of time if the particle initially started with 0 or origin. Correct? Fine. So make one thing sure, that whenever you have to analyze this kind of motion, you are going to analyze two things. One is a circular motion, another is the straight line motion. That is the method to analyze these kind of helical paths. And always keep that axis out of the plane, उस axis को out of the plane रखिए, which is having the magnetic field, और magnetic field जिस एक्सिस के अलोंग है उसको हमको आउट ऑफ द प्लेन रखना है, ताकि सर्कल को एनालाइज करने में आसानी हो. ठीक है? ओके. देयर इज अनदर वेरी इंपॉर्टेंट parameter of a helix, that is pitch of a helix. It is the distance traveled along the axis of the helix in one complete rotation. In one complete rotation. Okay. So pitch is equal to v parallel into time period if v parallel is constant, where t is 2 pi m by bq. Okay. Fine. Now let's take this question then. If we take this question, here field is 1 Tesla, v is 1 meter per second, angle between them is 30 degrees. So this component, it is the v parallel component, is v sin theta. So this component, that is v parallel, is v cos 30. So it will be root 3 by 2. V perpendicular is v sin 30. Right? Correct. Therefore, Time period will be 2 pi m by bq. So time period is and pitch will be so this is root 3 pi, correct? Pitch then will be root 3 pi. Question then. R we know will be mv perpendicular by pq, क्योंकि जो सर्कुलर मोशन हो रहा है वो तो v परपेंडिकुलर की वजह से ही हो रहा है, राइट? द सर्कुलर मोशन इज ड्यू टू v परपेंडिकुलर. Time period is 2 pi m by bq and pitch वो हो जाएगा v parallel into time period r by pitch कर देते हैं. Therefore, v parallel by v perpendicular will be pitch by 2 pi r. Correct? So can I say v parallel by v perpendicular will be this is the required answer. Right? This is the required answer.